Hello boys and girls, wanted to come to you with a video on how to calculate the surface area of a triangular prism. Now I showed this formula to a couple classes. I'm going to just reintroduce it here, and then for two classes it's relatively new. If we're going to calculate the surface area for a triangular prism, a formula we can use is surface area is equal to 2 times the area of the base, because we're finding the area of two bases. It's a triangular prism, cluing us that the bases are triangles. And we're going to add to that the perimeter of one base, and we're going to times that by the height of the entire prism. All right, and let's think about this, why this works. Well, if we find the area of the two bases, that's here. If we find the perimeter of the base, which is also this triangle, and then times it by the height, see how we're just covering up all these sides all simultaneously? It's kind of why this formula works. Now let's use this formula and start to substitute values in to really help us calculate the surface area. We know that area of the base is a triangle. So my triangle is right here. My triangular base is right here. Remember, it's a triangular prism, meaning the bases are triangles. So that helps me clue in right here. That's one base, and the bases in a triangular prism run parallel to each other, meaning they do not share any vertices, they don't share any edges. All right, so there's my two faces, my two bases, I should say, excuse me. And we know they're triangles, so it becomes 2 times 1/2. Now remember, the base is perpendicular to the height. Now notice I don't see a height on this one. I don't see any dotted line. This is not the height. We don't see any right angle. But if I look back at the other base, notice I have this dotted line here, and what's there? It's that little box indicating there's a right angle, meaning this 4 is perpendicular to this base. So that tells me now that we're going to take 1/2 times the base, which is 9, times the height, which is 4. Now I'm going to add to that the perimeter of this base. We have some decimal numbers here. It looks like it's 4.5 is the length of one side of the isosceles scaling triangle. 4.5, because all 3 sides are non-congruent. 4.5 plus 7 2/10 plus 9, and I could put 9 and 0/10 there. That would give me 7. That's 16. 16 plus 4 is 20. So that gives me 20 and 7/10. And now we're going to times that by the height of the prism. Now the height of the prism runs from one base to the other base. It looks like we're going from here to here. The height would connect these two bases, and the height in this situation is 8 and 1/10. So times 8 and 1/10. Let's do some multiplication here. 2 times 1/2, they just cancel each other out and give us 1. So we just have the area of the base is 36. So that is the area of both of these bases. Plus, we have 20 and 7/10 times 8 and 1/10. Well, let me go over here and multiply this. 20 and 7/10 times 8 and 1/10 gives me an answer of 7, 0, and 2. That's 0. That is 56. This gives me a 5, and this gives me a 16. I have a special guest here. Cameron Hess is dying to ask me a question, so let me try to rush through this video. 5 plus 2 is 7. We have 6, and we have 1. We move over 2. Okay, we have now, when we multiply the perimeter times the height of the prism, we have 167 and 67 hundredths. We're now just going to combine that with the area of the bases. I'm just going to slide this 36 right underneath here, lining up place values. If I'd like to, I could put a decimal and line up 2 zeros to fill up that tenths and hundredths place. We will now add that 7, that is 6, gives me a 13, that's 9, that's 10, that's 2, that gives me 203 and 67 hundredths square centimeters. That is how we can calculate the surface area of a triangular prism using this formula here. 2 times the area of the base plus perimeter times height. Okay, have a good one. Take care.